Hello everyone, welcome to Vijay Chemistry channel. Previous two videos, mole concept, we discussed about AMU, atomic mass unit, relative atomic weight, relative molecular weight. Okay, this all. Today we are going to discuss gram atomic mass and gram molecular mass. What is the difference between these two? If you observe the lecture, atomic weight or relative atomic weight or molecular weight or relative molecular weight, there were just number which indicates how many times heavier than 1 by 12th part of C12 isotope. Means just number, there is no units for that. But today what we are going to discuss, gram atomic mass or gram molecular mass. There is a particular units. Okay, molecular mass or atomic mass expressed in grams are called gram atomic mass or gram molecular mass. But simply we express it in grams beside the mass number means that is not gram. Exactly, we should know the clarity. Why? Because of that 1 gram, just we are mentioning gram means gram molecular mass we are telling. What is the difference between these two? Okay, atomic mass unit is nothing but just one small atom, 1 by 12th part of C12 isotope. If you come to the gram atomic mass, gram mention means in that 1 mole value. 1 mole is equals to 6.023 into 10 to the power of 10 to the power of 23 particles. Okay, so we mentioned gram means that contains 6.022 into 10 to the power of 23 particles in that. Okay, like that information it is given. Gram atomic mass, gram atomic mass, gram atomic mass. What is meant by gram atomic mass? Atomic mass expressed in grams. Simply, atomic mass, atomic mass expressed in grams. So as per this definition, directly we can say representation 12. For example, atomic mass is 12. The 12 expressed in grams, 12 grams mentioned means that is gram atomic mass. Okay, generally most of the teachers used to say like that, but there is a meaning for grams. Why we just grams mentioned means we are telling gram atomic mass. What is the difference between the normal atomic mass, gram atomic mass? Okay, you should know clarity. So here carefully listen. Just I am taking carbon. I want gram atomic mass of carbon. Gram atomic mass of carbon. Atomic mass of carbon. Gram atomic mass of carbon I want to calculate. Just you remember, you listen one example clearly, automatically remaining you will get it. Why we should mention that? Why they will say directly mention gram atomic mass over like that. Okay, so here gram atomic mass of carbon. From starting onwards, one AMU. Okay, we taken a small element. Take an element. Uh, Here I am drawing. Element is made up of same kind of atoms. Already we know. Atomic mass unit is nothing but a small part of one atom. We take it out, that we divide into 12 parts. 1 by 12th part we considered as AMU. So, first AMU. AMU value how much? 1 AMU is equals to 1 point, sorry. So, after taking the atom, that atom carbon, we divided into 12 parts. We divided into 12 parts. Yes or no? We divided into 12 parts. One part, 1 by 12th part, value how much? 1.66 into 10 to the power of minus 24 grams. Like these atoms, how many are there in the element means 1 mole value 6.022 into, or some books 2, 3 also they will go, no need to worry, 6.022 or 2, 3, no problem. 10 to the power of 23 particles are present like that. 6.0 10 power 23 particles are atoms means no that many atoms. The particular atom, how many parts we divided? Carbon now 12 parts we divided. One small unit value how much? 1 by 12 part 1.66 into 10 to the power of minus 24 grams. Like these atoms, how many are there in an element means 6.022 into 10 to the power of 23 atoms are there. Okay. Now, if you multiply this all, 16 into 6, almost 96 only. Okay. So, it's a value completely, if you multiply, you will get 9.99 into 10 to the power of, here 10 to the power of minus 24, here 10 to the power of 23. So subtract, you will get 10 to the power of minus 1 grams are there, no? Grams. Yes. Now 12 into this 9.99 is nothing but a round of value 10 only, no? I am taking 10 into 10 power minus 1 grams. Now 12 into 10 into 10 power minus 1 is nothing but 1 by 10, can we write? 1 by 10 grams. Now 10 get cancelled. Remaining what is there? Gram. How many grams? 1 gram. So 12 into 1 gram is nothing but 12 grams. Gram atomic mass of carbon how much? 12 grams. Gram atomic mass of carbon how much? 12 grams. Okay? Understood, children? Like this, gram atomic mass of carbon 12 grams. If you take gram atomic mass of nitrogen, only protons and neutrons change in every element, but this AMU value no change, and number of particles no change. Number of atoms also fixed for every element. 6.0 to 10 power 23 atoms in one element. Okay, so when these both are common, the value will get always here like this only, 10 by 10 cancel remaining gram. So if you take nitrogen, how many grams? 14 you will get here, 14 grams. Okay. Sodium 23 grams. Calcium, its mass number is 40 grams. Okay. Like this for every element, same calculation. So instead of calculating this all directly, we are expression directly in grams, because finally we'll get in grams, 12 grams. That is what atomic mass expressed in grams. Whatever you got atomic mass or relative atomic mass, if you express in grams, that is only gram atomic mass. But 1 gram atomic mass we are mentioning is nothing but how many particles are present in that. 6.02 to 10 power 23 particles are present in that. Okay, gram you mentioned means it contains 6.0 to 10 power 23 particles. Is nothing but 1 mole value, that one. 1 mole value. 1 mole is equals to 6.0 to 10 power 23 particles. Okay, 1 gram is nothing but 1 mole value particles are present in that. If you not mention grams, there is no that many particles. Just that is a relative atomic number. How many times heavier than 1 by 12th part of C12 isotope? Relative atomic mass. That's it. Comparison. But gram mention means this many particles are present. How many particles? 6.0 to 10 power 23 particles are present. Okay? Like this. You can calculate for any element. Now gram atomic mass of carbon 12 into 1 point. This common. This is common for every element. These both are common. Only here number change. Nitrogen means 14, oxygen means 16, sodium means 23, like that. Okay, calcium is 40, like that. Here will change. But this area common. This multiplication, this only will get. This simplification 9.99 is nothing but 10 into 10 power minus 1. Same thing. 10 get cancelled. Finally, gram remaining, that gram into this particular atomic mass. I hope you understand. Yes, gram molecular mass. Molecular mass expressed in grams, same like above. Gram atomic mass have we discussed. Gram molecular mass we are going to discuss. See here, for example, I want gram molecular mass of carbon dioxide. Gram molecular mass of carbon dioxide. Gram molecular mass of CO2. Yes, we discuss now. First, what we should take? It's molecular mass. Carbon, oxygen. Carbon mass number is 12. Oxygen, sir, 2. 2 into 16, 32. 12 plus 32 is nothing but 44 molecular mass or relative molecular mass. So, molecular mass of carbon dioxide is 44 into 1.66 into 10 to the power of minus 24. That is common because 1 by 12 part of C12 isotope they considered. Minus 24 grams. When we mention gram molecular mass, immediately gram is nothing but how many particles are present in that? 6.022 to 10 power 23. 6.022 into 10 to the power of 23. Molecules are present in that. Particles is nothing but atoms or ions or molecules or electrons or protons or neutrons. Whatever as per question we should follow. So, how many particles are present in that? 6.0 to 10 power 23 particles are present. Same like previous calculation, 44 into this both when we multiply 1.66 into 6, you will get a 9.99 into 10 to the power of minus 1 grams. 44 into 9.99 is nothing but 10 round of value 1 by 10. 10 power minus 1 is nothing but 1 by 10 grams. 10 get cancelled. Remaining 44 grams. 44 grams. Okay, this is about gram molecular mass. You take any element, you take any molecule, find out first their relative molecular mass, then go for same. This all not required directly. You can write gram expression in grams that particular relative atomic mass or relative molecular mass. That is what we are calling gram molecular mass or gram atomic mass if it is atom. Okay. Yes, I hope already you know how to find out molecular masses. That is what that concept I not explained completely. See here, two atoms are in this total, three atoms are there. The total three atoms are only molecular mass. Carbon 12 mass number, oxygen 16 mass number, two oxygens are there. So 2 into 16, 32. Total mass number is 44. Molecular mass of CO2 is 44. That expressed in grams, gram molecular mass. So whenever you express it for any molecule or any atom grams, that contains how many particles? 6.023 particles. That you have to remember. Okay, children? Thank you.